All right, it's taping. All right, guys, today we are, most of the week, we've talked about our main focus has been adding, subtracting integers, okay? With addition and subtraction of integers, you're talking T-charts, you're talking number lines, it's the same kind of strategies, okay? However, I'm here to tell you, multiplying is completely different. So we're gonna be dealing with integers still, but multiplying is different, okay? So before we get started, I want to give you guys a quick review. Now, probably a lot of you guys know this, but I want to make sure I go over this, okay? And it is to do with this lesson, but it's also to do with word problems in this lesson as well as in the future, especially on your test, okay? So here's what I want to talk about. I want to talk about the concept of what multiplying really is. Okay, so I'm going to take you back to like 3rd grade, maybe 4th grade. All right, that's what we're talking about. Now, here's a little imaginary story. So here we go. Okay, let's say that we were in 3rd grade. Right? And a lot of you guys got to like that. I thought of that. Okay, so we're in 3rd grade, and we are learning multiplying for the first time. Okay, so here's what I would do as a teacher teaching you math. I would say, okay, guys, we're going to do an activity. So you're with your groups. Here's what I'd like you to do. Please go ahead and I'd like you to grab 3 hula hoops over on that side of the room. So you guys would grab them and you would put the hula hoops down on the ground. Okay? And then you turn around and I would say, okay, guys, so see that bucket of marbles over there? I'd like one person from your group to go get marbles, and your goal is to put 2 marbles in each hula hoop. So send another member over there, they grab the marbles, and they put 2 marbles in each hula hoop. Okay? And then I would say, okay, guys, how many total marbles do you guys have in there?
7.
All right, so, okay, so we have, it's a total of 6 marbles, okay? So here's what I want to point out, okay? Here's what I want to point out is that we have, with multiplication problems, I'm talking about the concept, I'm not talking about math facts, I'm talking about the concept of multiplication, okay? Here's what multiplication is. It's when you're given an equal size groups, okay? And those groups will have a certain size to them. Now, sometimes the size is how many or how large, okay? But it'll have a certain size. And with a multiplication problem, it's going to be asking you what's the total. Now listen, this is a little easier. I drew a diagram, but sometimes you'll have to use your imagination when it comes to multiplication. Okay? So we'll see some word problems like this, and with multiplication problems, you should be able to build some kind of diagram that represents something like this. It might not be like this, but it's similar. So here's what I'm talking about. The hula hoops were the groups. Okay? 3 of them. The marbles was the size of each grouping that goes in the hula hoop. There ended up being 2 in each. So when I asked you what's the total amount of marbles, being 6, okay, I was asking you a multiplication problem. And of course, you multiply. Okay, that's just an example of what multiplying is. Now, a little foreshadowing is Monday we're going to talk about dividing. I'm going to use the same problem. I'm going to show you the difference between multiplying and dividing. But when it comes to word problems, the biggest thing to help you understand how to do a word problem is by having good reading comprehension skill. And when it comes to math, understanding the concept of what multiplication looks like is a great reading comprehension skill. Okay? So and we'll talk a little bit about this at the very end of the lesson. Again, we'll come back to this because we'll talk about a word problem. Okay. So here's what I would like to do though is let's go ahead and let's move to some examples. So go ahead and you have your book open to page 74. Okay, paper's out. Let's go ahead and take a look at problem number 3. Okay, we're going to pause from the concept part of it and the word problems. We're just going to talk about solving simple problems, okay, or simpler problems. All right, the computation part of it. So here we go. Number 3 in your book, of course, says 8 times negative 3 times negative 5. So it's not exactly really simple, but it's still a good problem to start with. So here we go. Here's what you're going to do. Okay, in this particular case, right? I mean, if you're looking at something like this, you would say, okay, it's all multiplication. I'm just going to go left to right, like following order of operations. So here's what I'm going to start with. I'm going to go ahead and start with those two numbers there. Okay? So what we're doing is we're taking 8 and multiplying 8 by negative 3. Okay? Now, so 8 times negative 3, here's what you need to realize. Okay? Step one is you're going to ignore the signs, meaning the positives and negatives when it comes to multiplication and division. You're going to ignore the signs, and you're going to just multiply the numbers. Okay? Probably the best way to say that in actual 7th grade terms is we're multiplying the absolute values of both numbers, right? 8 times 3. So we come up with 24. Now, step 2, of course, is the most important part, because this is where it all lies, all right? And here it is. Write these rules down with multiplication. Okay? With multiplication, if the integers have the same signs, meaning they're both positive. I mean, think about it, right? They're both positive. In elementary school, you multiply 2 positive numbers. What'd you get? You got a positive number. That hasn't changed. Okay? If you multiply a number, now, but the difference is, of course, if you multiply 2 negatives, it's still going to be a positive because they're still the same signs. Okay? If you multiply 2 integers that have different signs, bottom line is one is positive and one is negative. You probably could take a good educated guess. Our answer is going to be negative. If I made a little story about this, little imaginary story, and said, okay, guys, you have a bad habit of losing money. For 8 days, you lost $3 each day. How much did you lose? You lost $24. You see that? So a positive times a negative is still going to give you a negative. Okay, if they're different signs, it's a negative. Okay, now we can call this step star. All right, I mean, this is just a reminder. On a problem like this where there's 3 integers, please rewrite it. Rewrite it. It's not horrible to rewrite it. You're going to bring down your negative 5 here. Okay, and that's it. I'm going to repeat those steps with this. So, step 1, I'm going to go ahead and ignore the signs. 24 times 5. If I need to, I can go over here and do some what I can call scratch paper work. 20, that's 12, 120. And then I look here. They have the same signs this time. This is a positive 120.
So same sign.
Okay. All right, questions?
Can you also do the triangle? Positive and 2 negative?
See me after class and we'll talk about that. Okay. I don't like throwing new things out there without, and I don't want anyone getting confused during the lesson. But I may, so see me after class.
If it's a negative, why is it a positive?
Why are both negatives a positive?
Yeah.
See, when I taught 6th grade, I used to use integer tiles to show my students how that would work. But I tell you what, maybe we can find some time to talk about that. That's a great question. But if I went into detail right now, I don't think we'd finish our lesson today. You guys would be going home without knowing how to do some of the problems, okay? So I'll try to get a little something where I can show you guys maybe on Monday real quick, okay? Okay. Any other questions, guys? Okay, I'm going to have you guys try one. Ready? All right. Problem 18. Problem 18. All right. 18. Go. Okay, anyone need more time? Okay. Guys, at this point, we are not sharing yet. Try to read your notes. Try to look up the notes up on the board. Try to struggle through it to get through it first, and then I'll let you guys share in just a bit. For those of you that are done, go work ahead on similar problems where you can get some of your homework done there. Okay, checking in. How many of you still need more time? Okay, now 30 seconds. Turn to your neighbor and share your answer. Go. Okay. Here we go. From number 18, right? You have negative. I'm going to go ahead and write it up here. So we have negative 8. Sorry, here we go. Negative 8 times negative 20 times positive 5. Okay. How many of you guys used associative property and multiplication on this? Okay, here's what I'm talking about. It's all multiplication, right? I can multiply these two first. What's 20 times 5? 100. Associative property multiplication is a great little skill to know. Okay. They are different, so it'd be a negative 100. Okay, I could, since negative 8 is not in parentheses, I'll put that one in parentheses. A little easier than what some of you guys did. 8 times 100 is 800. Both the same sign, so it's a positive 800. Okay. If you went left to right, though, you probably took a little longer, but it would come out the same answer. Okay. Okay. Any questions on that kind of problem? Okay. Let's go ahead and look at a different type of problem. Let's look at problem number 7. Problem number 7. Okay, number 7 says simplify each expression. This is going to be a little different. Negative 3a times 7b. Okay? We have variables in here. They're not telling us what the variables equal. Okay? So, this is the first time that you have probably done a problem like this, and that's okay. All right? We actually are going to eventually get deeper into problems like this in a later chapter, but they squeezed them in here because they felt like with the skills that you've got, you could still do it. So I'm going to kind of give a quick explanation. Okay? So here's what you're going to do. Okay, first of all, I want to explain what I'm about to do first before I do it. Okay? What this really is this is negative 3 times A times 7 times B. It's all multiplication, right? So if I have, and you can write this down if you want, but you don't have to. This isn't a step, but negative 3 times A times 7 times B. That and that's the same thing. It's all multiplication. They've associated the 7b. It's a coefficient with the b, which we'll talk more about later. Here's the bottom line. According to associative property multiplication, can't I multiply the two things I know how to multiply, the 7 times the negative 3? Okay, so listen. Here's what you're going to do. Step 1 is multiply the numbers that you know how to multiply. 7 times the negative 3 is, well, 7 times 3 is 21. They're different signs, so it's a negative 21. Guys, don't leave that thing off. Because remember, like up here, right? Positive 20, negative 20. Look how far apart they are on the number line. They're different numbers. Okay? Negative 21. Step 2, you can say negative 21 times A times B. We still have those, right? But here's all you're going to do. And you need to make sure you do this. They're variables. They go at the right side of the number because number is called a coefficient. And I don't need to put a multiplication sign. I just put it negative 21 AB. You cannot simplify AB because we don't know what they are. And they just stay as the variables AB. That's it. So you multiply, because it's multiplication. You can multiply the other numbers, the numbers you know, and then just put the variables right next to it. Okay? Questions on that one? Okay. All right. Try out. Some of you guys already see it. Go ahead and try out problem number 23. 23. Go. Anyone need more time on that one? Okay, a few more seconds. Again, some of you guys probably could squeeze another problem in the next few seconds. Okay. All right, 30 seconds. Go ahead and turn to your neighbor and share. Go.
I got 81M.
Okay, I'm going to go ahead, and all I want is an answer. You don't have to tell me how to do it or walk me through it. I just want an answer. Bless you. Here we go. All right, seat number 1.
Positive 81 and 10.
Amen. Agree, disagree? Okay, looks like most of the class agrees with you. Here we go. So what are we looking at? We're looking at negative 9 times m times negative 9 times n, right? So step 1 is you're going to multiply, of course, the two integers. Negative 9 times negative 9, that gives us 9 times 9 is 81. They're the same, so it's positive. And, I mean, at this point, just know that bring your variables down behind, right? And now we have 81mn, remember, means 81 times m times n, but this is how it's expressed. All right, good job, guys. All right, any questions? Okay, here we go. Let's try another one. Oh, take a look at number 26. Okay, we're not going to do this problem together, but you might want to write the problem down, okay? Because what I'm about to show you is pretty important. Okay, listen. Do you see this negative variable here?
Yes.
Okay, anytime you have a negative either outside parentheses or a negative variable, what it truly means is you squeeze a 1 in. A negative j is the same as a negative 1j. Okay? So when you see a negative variable, it might help to realize that's actually a negative 1 in there. Okay?
Like every word.
If there's no coefficient, meaning if there's no letter in front of it and there's a negative sign, then it helps a lot of people to squeeze a negative 1 in there. Okay?
That's to show that because you multiply it with j, it will just be like 4j.
If you multiply it with, so you're multiplying, it's just a negative times a third negative. So that's kind of sometimes helps you guys out. If some people don't see the number there, they just kind of skip the negative. So you've just got to be careful. That's why I'm reminding you guys of that. All right, here we go. Let's take a look at problem number 9. Okay, number 9. Okay, this is an evaluation of expressions here. So it says evaluate each expression. It's 8j if j equals negative 11. I shouldn't have written that. J equals negative 11. So here's what we're going to do. Okay. Step 1, put parentheses where the letter is. Step 2, plug the number in, right? We've talked about this. So negative 11 goes in. And step 3 is to solve. So 8 times 11 is 88. Positive times a negative. They're different signs. Negative 88 is our solution. Okay, listen. I do want to get one more problem in. Okay, take a look at problem number 5. It's a word problem. Mr. Hepner bought lunch with his debit card every day for 5 days. Each day he spent $8. If these were his only transactions, what was the change in the account balance? Write a multiplication expression, then find and interpret the solution. So listen, I just want to set this up for you, referring back to what I said at the very beginning of class. 5 days. There's 1 calendar day, 2, 3, 4, 5 calendar days. Each day he spent 8. So negative 8, negative 8, negative 8, negative 8. So step 1, it says write a multiplication expression. Ladies and gentlemen, this is groups, equal groups of negative 8. So it's 5 times negative 8. Okay. Remember we talked about a loss of $8 or spending of $8 is negative. Then it says, then find and interpret the solution. So we have, or the product. So we have, of course, 5 times 8 is 40. They're different signs, so it's negative 40. So that would be step 2. And step 3, interpretation of the solution. Negative 40, you would say, Mr. Hepner's account balance is $40. Remember the negative, so $40 less. Oh, sorry. $40 less after 5 days. That would be one example. Okay. You do have to show, you have to explain what the 40 is and what the negative stands for. In this case, $40, the negative is the less. $40 less after 5 days. Okay. So that's step 3. Don't forget your interpretation. Okay. Any questions on that? All right, guys. Multiplying integers.